This is Math 2, 11.3b homework questions. That's Unit 11, Lesson 3b homework questions. You should have this worksheet either printed or handwritten off of the internet, or you picked it up from Clovis West. Okay. I'm going to do a few of these with you. It says up here, solve the following equation for x. Express answers as complex numbers in simplified radical form. Okay, I'm going to start with number 4. Now, the methods we have for solving quadratics is either factoring or complete the square. Now, I will tell you right now that none of these factor. But typically, those are the things you would try. Factor first, and if not, then complete the square. So let's pretend we tried, we looked, factors of 24 that add up to 8. Oh no, nothing works. Okay, the only other thing we can do is complete the square. So all of these are going to be solved by completing the square. All right, move over the 24. We've done that a few times. And right now, we're not rewriting, we are solving. Do you guys remember this difference? There's no y on this side, that is 0. So that gives me x squared plus 8x plus blank equals negative 24 plus blank. And I got negative 24 because 0 minus 24 is negative 24. Okay, and then we've done this a ton of times. You take the 8, cut it in half is 4, and 4 times 4 is 16. And what I add to one side, I must add to the other. And then I double bubble here. I know my two signs have to be the same because it's positive. The neighbor tells me they are both positive. And two numbers that multiply to 16 that are exactly the same, 4 and 4. 4x and 4x would give me the 8x in the middle. So x plus 4 quantity squared equals negative 24 plus 16 is negative 8. Now, if I was rewriting in vertex form, I would add the 8 back over. But since I'm solving, this is where I square root both sides. Square root, plus or minus, they undo. X plus 4 equals, 8 is not a perfect squared, but it does have pairs, 4 and 2, 2 and 2. So I have 2, 2, and a 2. The 2's coming out with a negative sign, so it's coming out with an I. So I have plus or minus 2i root, and then that 2 stays in. All right, plus or minus, because we took the square root of both sides. The negative came out as an I. 8 breaks down to 2, 2, 2, which is 2 root 2. So plus or minus 2i root 2. Minus the 4 to the other side. X equals negative 4 plus or minus 2i root 2. And that there is your final answer. Negative 4 plus or minus 2i root 2. Two solutions. These are not x-intercepts, but they are two solutions to the equation. And they're not x-intercepts because they're imaginary numbers. Imaginary numbers are not x-intercepts. All right. There's our two solutions, negative 4 plus 2i root 2 and negative 4 minus 2i root 2. And this is how we leave it. They are not like terms. That's as far as you can go. Okay, number 6. Subtract the 7. X squared minus 10x plus blank equals 0 minus 7 is negative 7 plus blank. Negative 10 cut in half is negative 5. Negative 5 times negative 5 is 25. You add the 25 to both sides. And we factor. The two signs have to be the same. And the neighbor tells me they are both negative. Two numbers that multiply to 25 that are exactly the same would be 5 and 5. And you'd get negative 10x in the middle when you check it. So that gives me x minus 5 quantity squared equals 18. Square root, plus or minus, undo. 18 is not a perfect squared, but it does have pairs. 9, 2, 3, and 3. So I have 2, 3, 3, and the 3's coming out, and there's no negative sign. So no I is coming out with it because that is a positive 18. So plus or minus 3 root 2. X minus 5 equals plus or minus 3 root 2. Add your 5 to the other side. So you get positive 5 plus or minus 3 root 2. Those are not like terms. You cannot add them together, not even the 5 and the 3, because the 3 is attached to the root 2. It's like saying 5 plus 3x is 8x. You can't do that. 5 plus 3x is that. 5 plus 3x. You cannot add them. This is it. That is your final answer. Okay, I am going to jump to the back and do some of the review problems. Okay, now I'm going to do from this column here, and I'm going to kind of jump around. I'm going to do number 12 first. 5i squared is 5i times 5i. And because it's a monomial, you could distribute the exponent. 5 squared, I squared. 5 times 5 is 25. I times I is I squared, which is 25. I squared is negative 1. So 25 times negative 1 is negative 25. Okay, next one. 3 times 4 times 5 times 6. Do it in any order that you want. 3 times 4 is 12. 12 times 5 is 60. 60 times 6 is 360. I times I times I times I is I to the fourth. Now remember, we cannot leave I to the fourth as part of the answer, so we write down our little chart. What does each one equal? And there was the chant. Remember, I won, negative sandwiched in the middle. I won, negative sandwiched in the middle. You're celebrating, you won your game. I won, negative sandwiched in the middle. Okay, I to the fourth is positive 1, so I have 360 times positive 1, which is 360. Okay, I want to compare numbers 10 and 16 as well as 9, 10, and 16. Do you see the difference? They look very similar because of the double bubbles, but these two up here have plus and minus signs. This one does not. This one is the double distribution. These two up here is the one where you drop the parentheses. This one you just drop it because there's nothing to distribute. This one you distribute and then drop. This one down here is different because there is no plus or minus. You can finish these up here on your own by combining like terms. And that became positive because I distributed the negative. Combine like terms and you're done. Okay, this one is a double distribution problem. So I'm going to do 6 times 5 is 30. 6 times negative 2i is negative 12i. And then I'm going to do 4i times 5 is positive 20i. And then I'm going to do 4i times negative 2i is negative 8i squared, and combine the like terms right there in the middle, just like they usually are. 30, and then I get positive 8i for negative 12 plus 20 is positive 8i. And then here we go again, negative 8i squared. I squared is negative 1, so negative 8 times negative 1 would become a positive 8. Negative 8i squared becomes a positive 8. So I have like terms again, and I end up with 38 plus 8i as my final answer. Okay, 18. Is 18 more like number 12 or more like number 16? You see it's a quantity squared like number 12, but because number 12 was a monomial, you could distribute. I wrote it twice, but you could distribute. This one you cannot distribute. You do have to write it twice. You're forced to. There is no other way. Okay, and then you double distribute. 2 times 2 is 4. 2 times 7i is 14i. And then you multiply here, plus 14i plus 49i squared. All right, combine your like terms. These are not opposites because they are exactly the same sign. So that gives me 4 plus 28i, and here we go again. We have an I squared. I squared is negative 1. So positive 49 times negative 1 becomes a minus 49. Plus 49i squared becomes minus 49. Combine your like terms. That gives me negative 45 plus 28i as my final answer. Okay, moving along. I am going to jump down to these last three, and we've done these a few times in our previous unit, so we're just talking about them again. Which one reveals the maximum value? Which one reveals the zeros? Which one reveals the y-intercept? Let's do y-intercept first. Y-intercept is when you make x 0. Which one is the one that's where you plug in 0, 0, and it's the last number? Plug in 0, 0, it's the last number. That's this one here. Do you remember? 0 plus 0 plus 15. 15 is your y-intercept. So that one's it right there. B reveals the y-intercept. It's the one in standard form. Okay, which one reveals the max? Which one reveals the x-intercepts? X-intercepts is factored form, and factored form is that one there. Factored form, C. If you were to find your x-intercepts, you'd plug in 0 here, and you'd put x plus 7 equals 0, x minus 5 equals 0. The negative 4 doesn't count because by itself it cannot equal 0. That's where you do the zero product property. You don't have to do it on this one. I'm just showing you how you would set it up like that. So that's the one where you find your x-intercepts quickly and easily without changing the form of the equation. Reveals the maximum value. Maximum value is referring to the vertex. Whenever they're talking about maximum value, they're talking about the vertex, the y value of your vertex. Which one of these is vertex form? That's that one right there, the A. Vertex form is where you say, oh, opposite of the inside, outside stays the same. Your maximum value would be the 7. Okay? That is it for these homework questions.